Hello everybody, so today I will be talking about EasyBuild. So what if you no longer had to install a broad range of scientific software from scratch on every laptop, every cloud instance, every HPC site, without actually compromising on performance, which you often have when you're using containers and stuff like that. So I'm Lara Peeters, if you're online or in here and you want to ask us a question, you can also use our Slack channel. So you can join our Easy Slack. And then we also have a private channel today for the hackathon and also for the next days. Also for people online, if they want to join and have questions, they can also ask them there. So what are the major goals of Easy? So with Easy, we want to provide a truly uniform software stack so that wherever you are on any Linux machine, you will have the same software available to you. That will also be without sacrificing on performance. We also one of the other goals was that we wanted to avoid duplicate work. So now we have tools like Spack and EasyBuild where you can admins at your HPC sites can already do automate a lot of the installation, but they still have to do the actual installation and run into troubles wherever they might be. We also want to use Easy to facilitate HPC trainings and development of scientific software. So how does Easy look like in a nutshell? A bit of a visualization. So we have Easy with a number of packages that are already available through it, like TensorFlow, OpenFOAM, PyTorch, Bioconductor, loads of stuff. And so once Easy becomes available and you install through CIRN-VMFS, by installing it, you can start using all these packages on your laptop, on regional HPC sites such as those in Flanders, or on the EuroHPC sites where Easy now is everywhere available, or on the cloud. So if you have a cloud instance you want to cloud burst, you can start using the software immediately once CIRN-VMFS is installed, so you don't have to go through the whole hassle of having to install your software. Or just on your Raspberry Pi. You can't compile GROMACS on a Raspberry Pi, but you can run it with Easy. So a quick demo time. So we have here a new instance. This was run up like half an hour ago, but there's nothing here yet. So if I do module, it doesn't know about module or anything. If you want to know if Easy is available, you check if CVMFS is installed by running ls on the directory, and it says no such file or directory. So if we go to our documentation, so you can install Easy very quickly and simply by just running these commands. So first it will install CIRN-VMFS. It will configure CIRN-VMFS to know about Easy. It will set some environment variables like this. The second one will set the quota limit for the cache. So that means that it will only, for all the software that it's going to use, it will only use that amount of data on your system. So if you're, for instance, running GROMACS, it will put everything of GROMACS in there. If you start running something else and the cache is full, it will throw away the file that you're no longer using. So it can also be a very limited machine that you're on and still be able to run lots of stuff. And then set up the CIRN-VMFS. So let me run this now. Okay. And while I'm letting this install in the background, I'll go quickly again to my slides until it's done. It will take about 2 minutes probably. So these are the installations that I just went through already. You can also use other tools to install it if you can't install it natively, because now I need root to install it, but on an HPC site you often don't have it. You can also run it in a container on HPC, or you can use CIRN-VMFS exec. And we also have this documented in our documentation if you need other ways to get access to CIRN-VMFS. Once CIRN-VMFS is installed, you can check out what's in the CIRN-VMFS is just a file system. So everything in Easy is just accessible through the file system. So on the left, you can see all the different architectures that we're supporting right now for all the installations. So we have, for ARM, we have a number of targets like Neoverse N1, V1, x64FX, and NVIDIA Grace. And for x86-64, we also have a number of targets. And what happens in the background is that EaSI automatically will check what your CPU microarchitecture is, and will then also pick the right one, set up the environment variable, and once it's set up, you can start loading modules, running it, and stuff like that. And I will see if the installation is done, and it is. So now if I do ls cvmfs, okay. Right. So now it does an ls and it's there, but you don't see anything. So SturmVMFS works similarly to HTTP because it's also built by CERN and on those protocols. So I actually have to know the site that you're or the target that you're looking for, similar to when you're looking for a website. So for software, easy.io. And once you do an ls, it will take a while because now it's going to a mirror somewhere, and depending on where your VM is done up, it can take a little bit longer to get to the data, but it's now there, and so EaSI is available, and now we can sort the environment and start using EaSI. So we now have, So at the moment, we have two versions in EaSI. We have the 2306, which is the older one, and the 202506. Some software is not there yet in the newer version, but we'll start off with the newer version, and we'll switch to the older one when something is there that we want to try later. Then we load the environment. I'll do the LMOD environment, and then run bash, and then now it's going to set it up. And here you can see now the versions that it's been set up. It also says which architecture. So we're here on an ARM Neoverse N1. It didn't find any accelerators, but if you're on a system where GPUs are available, it will also set up the environment to run GPU software. And so now it's ready to use. So now if I do, for instance, module avail, GROMAX, BAMPS, bioconductor, it will find the modules. And so we also have a demo available for EaSI with some scripts in them. So I'll run some scripts quickly. So here we have a number of demos. Let's start off with the GROMAX one. So what is in here? There's just a script file. I'll show you quickly what's in there. So what it does, it will check the version of EaSI that is running, then pick the right version that it is. So in this case, we have 2025.06 loaded, so it will pick this version of GROMAX. And then it will download a file, unpack the file, and then start running GROMAX. Here. So let's do that. So the first time you start running software with EaSI, it can take a little while because it first has to get all the files from that mirror server to start running it and loading it in the cache. For Gremlin, this will not take that long because Gremlin does not have that many files. But if you're looking at TensorFlow, it can take up to a minute to get all the files. But once it's in the cache, things will start becoming faster and faster. So as you can see, GROMAX is now already running and will be done in a minute. So let's go back to the slides. So this is a high overview of EaSI. So on top, we have our software layer, we have all the installations are installed. Because to make EESSI portable, all the libraries that are used by the software installed is linked to the compatibility layer, so it's in no way connected to the host operating system. Only for like GPU, we have to build in some gates so that it can use the drivers and stuff like that. But for all the rest, it's using our compatibility layer, and all these things are in our file system layer, which is provided to CERN BMFS. Then we also do a lot of testing. So we're using Reframe. We also have our own test suite, a portable test suite that you can set up for your system, and you can start running the tests. And also the software that is available in EasyBuild. If you're building your software with EasyBuild, you can also run our test suite on your local installations. And at the moment, we're installing Intel, AMD, ARM, and also RISC-V. So we already have a stack for RISC-V if you have access to those machines and you want to test. Then how CERN BMFS looked. So I told you that it could take a while sometimes to get stuff. So this is like the network that we currently have. We have our central server in Groningen. So that one is the only place where you can write and add stuff to the repository. And yes. And then we have a couple of mirrors. So we have a mirror, two mirrors in AWS, one in the both in the EU, and then we also have an Azure one in the US. And then in the UK, the RAL have their own mirror cluster set up. And then on your side, you can have proxy servers or different caches that you can make the software quicker. Then EasyBuild becomes available on your HPC cluster, on your laptop, or in the cloud. So let's go through some new releases and developments within EasyBuild that we have had in a couple of last years. So now we have one main repository, which is software.io, and we have two versions. So we have 2023.06, which has tools change FOSS 2022b to FOSS 2023b. We have over 1,000 software installed in there, and over 6,000 unique packages. We also, so in 2025.06, we're trying to catch up to all the software that this was in 2023 or so. Now we have already over 700 packages supported, and 400 unique packages, and there we're supporting FOSS 2024a through 2025b. And we also have dev.easy.io. I will come back later to it, or what it's about and what isn't there. So an overview of the available software. So currently we have more than 2,000 software installations available over all the supported CPU targets. We have 15 supported CPU targets, both in ARM and x86, and also our generic targets for RISC-V. Over 750 software packages, and that's not included like all the extensions that Kenneth also mentioned in his last slide that we bundle in packages. So a lot of Python packages and R libraries are not counted in these, but are available in EasyBuild. So we have so I think those are mentions. If you want to know if your software is available in EasyBuild, you can check out our documentation by going to the link in the slides. And then you can easily search for a name like Bromax or whatever, or Siesta or Quantum Espresso. It will tell you which CPU targets are supported. This should be in most cases, so should be all that we have for like small packages. We have from for packages, sometimes we have some discrepancies between the x86 and the ARM, but these are becoming less and less, and it will also say which versions are supported and in which easy version and stuff like that. So this is a bit of the evolution of the software available in 2022.06. So it started building in November 23, and up until now, where for the software installations, we have now over 16,000. Then for the unique packages and modules, So we have around 1,200 modules and then over 600 unique software packages. For 2025.06, we started around June, July 2025. We now have around 11,000 software installations over all the CPU targets, and then so many modules. Okay. So what are our supported CPU targets? For AMD and Intel, we have 5 generations of Intel CPUs. We have Haswell, Skylake, Cascade Lake, Ice Lake, Sapphire Rapids, and then we also have 4 generations of AMD CPUs, Zen 2, Zen 3, Zen 4, and Zen 5. I think Zen 5 at the moment is still hidden, but it's already there. So when you're on a Zen 5 machine, Easy will automatically fall back to Zen 4, but if you set like a small environment variable, you can also rely on the Zen 5 stack instead. For ARM, we also have 4 different CPU architecture. We have Fujitsu H64FX, NVIDIA Grace, and then Neoverse N1 and V1. For both x86 and ARM, we have a generic fallback architecture, which should run on all systems available. If you have something very, very, very old, it might not run, but we hope you don't run into that. So then we also have a RISC-V stack, which is a work in progress, and that one is only available through dev.easy.io. Then the supported GPU targets. So for NVIDIA CUDA, we have different generations of NVIDIA GPUs available. So for 2023.06, we have CUDA compute capability 7.0, 8.0, and 9.0 for those different GPUs, which support those different GPUs. And for 25.06, we have those also, plus then 12.0 and 10.0 on top of it to support more of the GPUs. Can the window maybe open again? This is getting very long. Then for AMD Rockham, it's still a work in progress to get AMD GPUs supported, but we're getting very close. In the last EasyBuild release, we now have Rockham 6.4.1, and one of our colleagues at the EasyBuild user meeting also did an in-depth dive into all the GPU stuff that is done with Easy. So if you want to learn more about this, you can check out this presentation, which is slides and recording are available online. So to facilitate all these installations and the thousands of installations that we already have, it will be very hard if we had to do all of this manually. So we have a EasyBuild bot deploy, which automates everything. So all the software installations that are deployed within Easy are built via a bot. It's a semi-automatic installation procedure where we still keep a human in the loop. We talk to our bot via pull requests in our Easy software layer repository. So if you want to contribute to Easy, you don't have to have access to all the CPU targets that we are supporting. You can just test it on some targets and then, and then contribute, and then we will test it on all the other targets. And if you then run into trouble on targets that you don't have access to, we will also help you to get the software fixed and working. I forgot to remove that in the slide. But I'll talk more about contributing to Easy and using the bot tomorrow. So the build test and deploy bot is a bit of an overview. So this is how you talk to the bot and how you, then you can track what is happening. So it will both test the build, it will do the build and report on it back. And then it will also run a test suite on top of it, and it will also report if the test suite has come back okay or not. So a workflow for EasyBuild. So contributors just open a PR to the Easy software layer. It will be checked by one of the one of the reviewers. Once they say it's okay, it's looking okay, it will start submitting jobs. So it will submit all the jobs. If the jobs are okay, it will and the reframe testing is okay. The software installation garbles will be moved to an S3 bucket. Then it will be picked up for deploying it to our Stratum 0. It will open a PR for staging before deploying it on the Stratum 0. There we'll have another check by a reviewer. Once that check is okay, then EaSI gets deployed to the repo. So yeah, I already mentioned a lot about reframe, and so we find software testing important in EaSI. So we already have a lot of smoke tests and sanity checks in EasyBuild, which Kenneth mentioned earlier in his slides. But so on top of that, we're also having a regression test via our EaSI test suite. So it's a collection of portable tests for software available in EaSI. It's not supporting all the software that we have about, I think, 10 to 15 tests now available for different packages. It's running, you can select the size that you want to run the test with, so it can run from 1 core to 60 nodes and everything in between. It's also running periodically on a number of systems with daily and weekly runs. It can also be used on your own software stack if you're using EasyBuild to build your software. And so we hope with periodic runs of this test suite to catch performance regressions. We also have an EaSI dashboard. So these are the number of sites that are running the tests regularly and also uploading the data. So for instance, these four are at Ghent. This is our Magic Castle cluster. And then we also have a number of sites, surface in there as well. And so this provides also system monitoring. So maybe, for instance, at Surf, they found some bug in their system through the regression testing because, they weren't really paying attention. And then, you can clearly see it in our dashboard. So it's also a cross-system performance comparison. If you would run the EaSI test suite, also periodically, you can also upload your data, so you can also contact us if you're interested in publishing your data on here as well. And if you want to check it out yourself, the link is at the bottom. Maybe I'll go quickly through this, but I'll also go more in depth with this tomorrow. So if you can also build on top of EaSI with, for instance, EasyBuild, then you have a module called EasyExtend. You load the model, and the whole environment will be set up for you so that you can immediately use EasyBuild and everything is set up. You can also just install stuff manually on top. Then we have a build end module, which will also set up the environment where you can then start building manually on top of EaSI. And also with Spack, but we'll have an in-depth presentation on that tomorrow, how to use Spack on top of EaSI. So here a closer look at dev.easy.io. So on the left, we have our software production. So dev.easy.io is meant to be for temporary installations. So also for developers who want to test pre-releases, they can install dev.easy.io on a limited number of targets so that they can also run bigger tests because it becomes available on HPC sites through EaSI. If it's set up, if dev.easy.io is also set correctly there, so then they can also do bigger runs. But at the moment, dev.easy.io is limited to MultiXscale because EaSI is currently being developed under there. But we hope to expand this to other developers and other codes in the future. Further integrations. So EaSI is now also part of the European Federation platform. Ella will talk about that later. EaSI is also available through the European Open Science Cloud. So there's EaSI compute nodes, which you can just spin up, and then you land on the node where EaSI is already available. where we can start working. Then there's also integration for easy and open on demand. So where the module list becomes available through interactive apps. This is not upstream yet. I think this was development work by HPC now, but I think it's gonna become, upstream in some points. Then also Spack, which we'll talk about more later tomorrow. So training and disseminations. So every Monday we have an easy happy hour. We talk like 15 minutes, 20 minutes about a single topic, go in depth to it, and then have like a discussion after. So if you're interested in that, you can join us. There are, I don't know. At the moment, there are none because we now have our webinars, but they will start up again mid-June. So as I told also earlier, so we have our webinar series. We had one in 2025. So if you're interested in one of these topics, you can revisit them via our YouTube channel. And then we now also currently have our spring edition 2026 running. So we already had our 3 first are now done. So the recordings are on, for the first 2, they're already available, the third are done yet. But if you're interested in any of the upcoming topics, you can also still register for the introduction to CERN BMFS or using EESSI as a base software stack. So we are doing a number of events with EESSI. We have the podcast, many presentations. We did a hackathon last year at the EuroHPC User Day. We also have our EasyBuild user meeting and more stuff. Then we were also in 2024, we were recognized by HP Wire as the best HPC programming tool or technology, voted by the people. If you're having trouble with support for installing, using, or contributing to EasyBuild, you can report anything via our GitLab instance, EasyDoc support. This is, okay. So all this work is being funded through MultiXscale at the point. So all the development work that has been done in the last years was through that. And then, we also have sponsor credits from Amazon, and we also get other sponsorships from Azure that support us. And then here is a number of slides and info that you can visit if you have any questions or want to get in touch with us.
Thank you. Any questions? Yes. How do you submit or how do you use the dev.easy.io thing like who is eligible to submit like a development version of the package?
At the moment,
Essentially, people we know in MultiXscale.
Yeah. So at the moment, we have a number of these dev.easy.io. So they're under our MultiXscale. They're publicly available. I think so. Yes. Yeah, some. So we have like a dev repository for Espresso, but also for Lamps. So if you go in there, these are then set up for the developer. So in some cases, only the people that are actually working on the code can then have access to the bot. So in here we then also have pull requests. Let me see one. So this was like, this is development work that's done by the developers within MultiXscale who are building this all, packet, how do you call it? These are packages? Packages to, connect, plugins to Lamps. So in here you then have, so we do then different stuff like adding the patch that adds the code to the Lamps installation, but you can also do other ways. And they then have easy configs. So they also building lamps from a certain commit instead of a stable version. And then you can do different stuff. And then you also have the easy stack file. So in this case, it had to install all the dependencies and then lamps itself.
Yeah, you can see the bottom of the last line. That's the software commit. So that's the
So
one
this is
that is using to actually do the installation.
There's a whole setup around this. So for the dev EasyIO projects, each project has its own GitHub repository today. It could be GitLab in the future. But then also it has its own dedicated bot for doing these builds. And the bot is configured to listen to specific GitHub accounts. So not everybody can trigger a build. And even for deploying, that's a second permission that you need to get. So there's like a hierarchy of things you need to be open a pull request and maybe a private repository. You need to be able to have permission to talk to the bot to trigger builds. And then yet somebody else can actually trigger deployments into their EasyIO.
And then each project has like its own directory. So you have like the RISC-V and then lamps. And then in lamps, we just have then the version of Easy. Let's go for the 25 one. And then you just have the software installed. So then you just module use like the path that you're on.
And then the number of architectures there is limited. So there's no really good reason to do it for all architectures the way we do in the production repo. We're mostly interested in like specific cases, right? Especially things like vector instructions on ARM or something like that, where you want things that are going to break. Now, like every GPU, you don't need every GPU, but I do need one.
Target audience is developers who want to test the same software on different systems.
Yeah.
Pre-release builds, essentially. If they implemented a new feature and they're quite confident that it's working quite well, but they want to test it on all the EuroHPC systems, for example, they could install it in dev EasyIO. If that's available on all the EuroHPC systems and all the CPUs are covered, then you can easily run it. To help developers to do scaling tests, for example. And for now, it's limited to MultiXscale, mostly because there's a bit of setup required, so we want to keep it under control. But mostly, this could explode, right? All software developers want this. We need to do a lot more automation work and setting up some kind of authentication mechanism. We don't want to be babysitting all these things.
And we have to be careful, right? Because we're aware of what goes in, but if you don't care about the distribution stuff, everything, the licensing, everything, like somebody has to keep an eye on that stuff, right? So, licensing matters for
There's a question in the back.
Yeah, so my question is related to the site-specific software installation using this EasyXscape. The thing is like, okay, different sites have different tool chains. So, like, as of now, EC supports 24A and 24B. From my practical experience, maybe I can explain. Like, I was using one software for Lara. It's a mod-1 simulator of the mod-1 rewards. I have the EC config file. I installed it properly, but it's not in the upstream of the EasyBuild program. The thing is, like, it uses a different tool chain in the JSON of that stack. And so I tried with the EC, but I had to adapt it to the tool chain in the EC to make it work. It's not, I cannot use the same EC config file on EC. This thing I did, and also to the CUDA version. So I realized that locally we use this, we use the major version, but in the EC part we have to do this minor, major, minor, this kind of small changes I had to do. The thing is like, okay, different sites have different way of doing and the tool chains. So the kind of like all sites should at the end follow the same tool chain, or how is it? Like, you add more tool chains, or we should stick to the same?
We'll get back to this tomorrow as well when we talk about installing software on top of EC and keeping that local. But so the idea is that at least with FOSS tool chains, we support all of them from a certain point. I think 2023A is the oldest one we have. And we want to go forward with all of them. They're spread across 2 different easy versions. Eventually we'll also, or I think we already do LFOSS right now, so the LVM. We want to also do Intel, for example, but then we can get into questions like, can we redistribute Intel installation worldwide? We need to talk to Intel about that. Yeah, at least one of them is already there. And in terms of, let's say, standard toolchains and UNA versions, yeah, we make choices in Easy, and that's what everybody gets. Which already helps a lot compared to having different sides making different decisions, and then you have to adopt to everyone. If you adopt to Easy, you only have adapt to Easy, you only have to adapt once. Because Easy is exactly the same environment everywhere. If you have an Easy config file that works, and you make it work on top of Easy, then your, let's say, 80–90% of the work is done to also fit it into Easy itself. Because once you get Easy is the same thing everywhere. Same toolchain, same tool version, same dependencies. That's part of the selling.
In some way, we have to generalize to some extent because we also cannot adapt to every single person and all their little, different things that they want. But we want to make it also as easy as possible for them to then, click into their little stuff that they want to do different. So for instance, you can already, if you have like your own MPI library, you can already click that in and stuff like that. So it's like trying to be general and still be able to get the niche cases, but in some ways you're probably not gonna get all the performance out of it because to do that then you have to.
In that case, one could say EasyXscape is kind of like initial testing of some packages. At the end, everything has to be up, to be put upstream before phase, right? So then EasyXscape.
It's up to you.
For instance, for commercial software, it will never be upstream to Easy. So then you would only rely on EasyXtend to then install it at your site on top of Easy.
But you could have a verified recipe that you know will work with EasyXtend. So we can't distribute the package, but we can give you the recipe that is guaranteed to work any architecture that you have.
And I will talk about this tomorrow, but EasyXtend is also what we use ourselves to add stuff to Easy. So if you know it works on top of EasyXtend, okay, maybe you're only testing on one CPU, not everything you support, but it's one step in the right direction. So,
What is the idea behind reframe? I didn't get it. So you provide also reframe recipes to be able to do regression testing on the platform where you get Easy, so to be able to assess the performance of that machine?
Yes, so it's a little more than only the reframe recipes. It's actually a whole tool. You only need like a configuration file.
Yes, we call it a portable test suite, in the sense that the reframe tests are written such that as long as you give the test suite the configuration file, which tells it about things like system partitions and things like that, the test will work. And you don't have to change the test, which is very different from how people typically run reframe tests. So you have a lot of documentation and MultiXscale deliverables that explain what you need to worry about and take care of for that to happen. And right now, maybe you can show the documentation on that. It now has a dozen or so tests. It's always difficult to find when you dedicated things for that. It has a dozen or so tests, and we're running those tests on different systems, which then gives the performance results that Lara showed in the dashboard. We run the exact same test with the exact same software installations, because they're all run with Easy, all different systems. And then things start getting interesting. You can compare across systems. We're doing, on some systems, doing daily runs as well. And I mentioned that Surf at some point they did the system maintenance, they did the firmware upgrades, and then they saw the test becoming a lot slower all of a sudden. It's like, what happened? And they figured out there was a problem with the firmware upgrade that was filling in the active problem. So I wouldn't, it's not a benchmark suite, but by running it again and again and seeing things change, if they change in the wrong direction, you know something's very wrong. The software did not change, the test did not change, so something happened on the system. So it can be used to raise alarm bells after making it.
So at least it allows you to set the base performance or the base preference for consecutive runs.
For example. And comparing across systems is a lot harder, but if you're doing 10 times as slow as somebody else running the exact same installation, something looks fishy at least.
So the results of other sites also published publicly, so that I'm able to compare and say, okay.
This is fully public, what Lara is showing here.
Okay.
So we're running on Vega, we're running on a cluster in AWS, a Slurm cluster that we manage ourselves. We're running in Ghent, we're running at Surf, and all the data is public. But that's opt-in, of course. The systems allow us to share that data publicly. There's a lot of stuff in here. You can spend hours just looking at everything. And if you hover over all the dots, you'll get all the details of what was run exactly, which module, how many cores, and so on.
So the idea is to do this for end user applications like Lara, Roma, etc. Or to get also for base things like also bandwidth.
We also
to all things like that.
Yeah.
Whatever you can put in the reframe test.
Yeah.
And ideally, I think right now only with software available is easy to open source software. Quantum Espresso is in here as well. I heard some people mention that. Yeah, Romax tests.
So how modularize this? I mean, I'm from this BrainScales project that relies on Spack because we also do non-HPC projects, but we are still very much interested in this kind of testing. And Spack isn't good at testing compared to this, at least. Orders of magnitude worse, I would say. But for other reasons, we like Spack. So we would be also interested in, so I would basically be interested in seeing how modular this is in terms of the test execution and the specification.
So at the moment, so it will look the module system, so our test suite checks like the module system. So at this point, it's very stuck to the way that EasyBuild names modules and the versioning. So that's why it's only going to work with modules that, at this point, it's only going to work for modules that are built with EasyBuild.
Okay, but if we would define, let's say, Spack encapsulating modules that define the test suite, it could be executed.
Yeah.
Yeah, okay. So the reframe test essentially do a module load. So if there's a module available, it's enough. But it does make some assumptions on which environment variable that module sets that are specific to EasyBuild. Other than that, I don't think the tests make any assumptions on how the software will install. So in that sense, I think with a little bit of effort in the test suite as it is now, this is fully open source, you could probably also make it work with Spack installed things. And then you can also very easily filter which software you want to run tests for, and you can probably add like labels for Spack and EasyBuild installed software, whatever. So with a bit of extra work, this could work without the fractional installation.
Okay, thanks.
And then from that also, I don't know if you have good documentation on the dashboard, and to what extent that setup is open source, but if it's not yet, we can look into that. You could spin up your own instance of the dashboard with only your private data. I mean, there's nothing that we're hiding. I'm not sure if that's
the setup definitely is not maybe the sending.
Yeah, whatever. It could be. You can just contact us, like, how is this done? What's necessary to set up that front end? Because there's a database behind it. It gets messy pretty fast, but we're happy to share everything.
Okay.
Yeah.
You mentioned that the benchmarking is triggered by some commits with some requirements from the source repositories of codes, right? I would like to ask how often if the benchmarking could be triggered also in other times of the year with frequency and which flexibility there can be on choosing the machines.
So you mean for deploying in dev.io? So yeah, at the moment it's not being automatically spun up, but you could add all kinds of automatics that if you have a certain commit or you set a certain flag in your repository or something, or it could create like a pull request on having
But the computing hours were taken from, am I using your hours?
At the moment all those hours are then from the sponsored credits that we get from Amazon at the moment.
On that, and
From Amazon.
Yeah. Or the benchmarking.
The test suite, so the test we get is coming from our product. Ultimately,
it could come from
But not for the benchmarking, it's also the tests that are run at Ghent are the Ghent resources, the ones that serve in kind.
I mean, you could imagine a future where you apply for a big project. See, I wouldn't use this for CI, right? This is more like CP, right? So where you release it.
Yeah, but that's why I was asking resources because it's more expensive than CI, right?
So you could imagine that like you ask for a big project, and then people share that budget, but you never get direct access to the resource. You put the rebrand test in place, we run the test for you, and then your results appear.
Your resource.
With this project's resource. So rather than ask for a small budget, just do benchmarking and say, I want a big project that's going to run for a year that with a large-ish budget, but I'm going to cascade that budget to other projects. Right?
So, for instance, for running on Vega, we just have like a development project, and we don't come anywhere near the maximum hours that we have.
So these tests are typically pretty small. The current ones.
Currently, there's no way to input our projects to use our hours, for example. If I have to run benchmark, I may want to use my hours instead of yours.
So the test runs are essentially just a prompt that runs usually daily. You can do that in your own project and then pipe the numbers into this. We don't need access to the compute, you just give us the numbers and we can push them in the database.
If you push your software to easy and make the test suite and make the test in reframe, then it will just start running it.
Yeah, but depends on what level you want to go to, right? So it depends on how large you want to be.
Yeah.
Obviously, we're not going to be running like half a machine for you, right?
No.
Yeah. No, I had in mind that there could be different use models, because one could be I want to test the software before the release, and then the test suite, or another use case would be I want to run benchmarks like in a standard way.
Because, for instance, so these regular runs, they're not going, I think, over 2 nodes, but the tests are, we can run up, the test suite is set up that it can run over, to 16 nodes tests, but we're not running those regularly.
But it could run more, right? It's not like...
No, at the moment we don't have scaling for more. So then we have to add more scaling. Yeah.
As in the test could support more,
Yeah.
so it never run more. Right? But you could run more, you can take the test yourself.
This is a bit exploratory as well in MultiXscale. There's several codes being developed in MultiXscale as well. I want to show people like this type of stuff with a bit of work can be done, and can be done in a generic way with any code. Like one of the end results, let's say, of MultiXscale, this dashboard and the way to implement the tests and relying on easy for the installation. So that way you actually get stuff that's actually portable and that you can bring to other machines and put in more tests with other software. And overall, this was not very complex to put together, but we just need the right people like designing the dashboard so it's this user friendly. It's still complex. This was all work. Like which buttons do you give? How do you visualize everything? Which technology do you use to make these fancy boards? And that's me. But we found people in Surf who are very good at it. Okay. Any more bites?
How often do you update the software that is included in this game?
It depends.
It's user, like, we don't update it, right? We rely on other people to say, I want this, and ask for it to be included.
Okay. So I just tested the commands installed on this laptop, but I can see in the 2025 version some of the Siesta version, for example.
Yeah, so Siesta isn't in the 2025.06 yet, but yeah. So,
In the old one, so
I just see in the 2023 version the first Siesta version, but I changed to the 2025.
there is
we're still waiting for your PR.
I just thought that it's automatically exists easy complete.
Don't
No.
there's too many open questions. We just automatically see the new Siesta version, but which tool change we install? The very latest? Does that work? Is it compiled to new? I mean, what do you pick? So we need humans to give us the right.
And we're also not going to open a PR in Easy for all the software that is in EasyBuild. There's too much. We're going to be overrun. We're going to be snowballed by all the problems that will pop
We're
up.
getting close to 1,000 unique software projects in Easy already. We cannot keep up with it. And what is interesting, we also don't know. Like, is it worth installing Siesta 5.3 Okay. Is it worth waiting for 5.3, 5.4, whatever makes sense?
Yeah, that's.
So what we're hoping, and that's something that Lara didn't really mention, I think, but what we're hoping is that we can also convince software developers that it's worth their effort to install new versions of their software in this, because then, in some sense, it's a one-time effort. And then you run all the EuroHPC systems, and if people have questions, you say use easy, and the installation is there, just use that. Don't try to install it yourself. So to some extent, we're hoping to see that kind of convincement also happen. And we hope the effort is limited, it is effort, but that the effort is limited enough that the developers will see it as a big win. With GrowMax, we already see this happening where we're struggling with the new GrowMax version or test suite or a couple of tests failing for one of the CPUs. They come to us and say, we think we know what's wrong, or can you give us a bit more details? So without us asking them what's wrong or opening issues, they somehow seem to be keeping an eye on what we're doing, and when they see trouble, they jump in. Maybe that will happen for more enforcement. Thank you.
I have a similar question, or related one. So we have been, or we are basically looking into, because we don't basically provide the base layer, we rely on the system compilers. Using Spack. We have been looking into basically actively forward-looking into new compilers, because basically in the release process, if you end up deploying to JSC and they have just a new stage base layer that is to be deployed, it's basically delaying the release of a software stage. So we have been actively trying to look into basically swapping out the compiler layer early in release cycle, or even between release cycles, just to find problems with the individual software packages early. So have you looked into this in an automated fashion already? Because we are basically trying now, or we will be trying to optimize this in the future.
I think you should wait for Alan's talk. Okay. Where he's going to talk about using easy and CI like with the packages, where you can get all the software, including compilers, PCC, LLVM, everything that's in there, in a way that you can easily test and test across all the compilers. So that's maybe what we have. Yeah. So, yes, we've looked into these things, and they're actually quite good. Getting access to easy in GitHub Actions or in GitLab runners is just a YAML file, and you get access to all of the software that's in there.
But it's not completely automated because you still have to.
You still need to do that YAML file yourself.
Yeah, and then probably you want to do some kind of build that is opportunistic, and you try to catch as many nodes as you can get, and somehow collect those and maybe make some statistics. Maybe some warning was converted to an error in some new GC. That's something that usually happens, and then you have like 50 packages that need to patch. But it's always the same one.
I mean, it probably can work. So you want like just a compiling smoke test, right?
Yeah.
And that's probably fine. It depends a bit on your package, right? Because some things require a lot of RAM, right? Depends on what you're doing, right? How complex your package is. Will it compile in a reasonable amount of time?
Yeah, so for us, it's basically we built 8 top-level packages, 800 in total. We have no waste there. It's a large start-based environment. But so basically, we have contact with individual code owners, but it's really it's a curated software distribution basically there.
Yeah, maybe what you're after is a combination of Spack and CI stuff. Well, maybe we should Spack tomorrow with CI as well.
I won't. I remove the slide.
You can combine both things. Yeah. You can use Spack on top of easy and do that in the CI environment, and that's maybe what you're after. Yeah.
Maybe I didn't understand, but the SAM part of easy distribution, just use a single place, a single repository for binary package, or each side that in principle can use more than one, like
Yeah, you can rely on multiple repositories. So if you're using dev.easy.io, you're both relying on Easy repository, and then for the extra packages on top, you then have dev.easy.io. As a side, you could then also have a separate repository for instance, for commercial software, that you have your own mirror server where you're adding the.
May overlay.
Yeah, they can overlay on each other and click into each other. Yeah.
I mean, you hide the layers basically in modules, right? So, like you as a user, you won't really know where things are. And so one dependency will come from this place, one dependency will come from that place. You won't see it.
Okay.
So, like in CVMFS, there are different repositories. So, CVMFS software.easy.io, CVMFS some other location. Maybe that location is somewhere that you control. Like we use dev.easy.io, we use software.easy.io, but in Austria, for example, the Austrian supercomputing center is they're distributing their own package on top of these.
Okay.
So they use a base layer and then they distribute something else on top.
You can just look at it as subdirectories of files. That's really what it is. It's a read-only process that you cannot change. But just like you can install software here, software there, in your home directory, in project directory, on top of each other.
Okay.
Was that the question on the repositories or?
Yeah, I would like to understand if possible to have like another source that is, for example, more suited to a particular either group of person or
also, not everything has to come through CVMFS. Easy comes through CVMFS. You can install something in your home directory on top of the installation of CVMFS. Just files on the file system, whether it's CVMFS or raster or SSD, this doesn't really matter.
But how does this combine with the Gentoo prefix state?
So the Gentoo prefix is the most important thing that you're getting from there is the runtime linker, right? So the thing that actually loads the libraries, right? That's the thing that we control and the thing that we configure in our special way. So as long as you ensure that that's the loader that you're using, your executable is using, it doesn't really matter then, because it's just kind of, don't look in slash, look in this other location instead.
We'll get deeper into that tomorrow as well, when we installing software on top. We'll show some of the details. Okay. We still want to do the practical setup thing?
Maybe just you can actually open the presentation there, just the picture. That's all it really is. It's one slide in the shared folder.
Yeah, okay. I did change this.
The second one.
The second one, yeah. It's just to say that, like, we prepared a cluster in cloud, and that if you need somewhere to play around, you can use it for the week. It's there for the week, and so you can scan that barcode there. That'll take you to this hackmd. So we could also potentially use this hackmd to add nodes. So, for example, I just threw in the location where we plan to put all the presentations. So if you scan that barcode, you go to this location and it'll explain to you how to do the sign up. And so if you do want to play around, just try things out, you can get an account on that system. And it's just a small cluster in the cloud. And free there for the week. But you can use Easy itself. If you have access to Leonardo, you can actually use it on Leonardo as well. And maybe I'll add a documentation link that how to use Easy on Leonardo in that package thing. But we can add additional information. So if people have questions about certain things or they come up frequently, we can update this. So it's just if you want to sign up, you can, and I'll approve your account, and then I'll let people know that things are approved.
That's just to make it easy. If you want to prefer playing in your own environment, whether that's Leonardo or whatever, we can help out as much as we can. So if any more standardized environment, we make it easy for us. And you are allowed to use Spack in this as well. Okay, then somehow we're back on time. Looks like we've added up enough buffer for ourselves in the agenda. Good, so yeah.
Are there any other questions? If not, we can go ahead and return it to the towns in the same place of the Gothenburg. So,
And we should make sure we're back here at 2, because Massimiliano already told me they may need a bit more time for the stacking than
yes.
we planned. So yeah, we start half an hour.
We may shorten the slide, but yeah.
Yeah.
That's
I
right.
can come back on time.
Yeah.
I set an alarm just to
One question about certainty of investment. Do you have any statistics about like how much data you're transferring? Like
How much data we're transferring?
like to send like you have like a central installation or like this thing in the Netherlands? Do you know how much is like if I access your VMware then I'm downloading stuff from some server?
Yeah.
Just wondering how much data is being.
You can ask Stevie and that. You can ask how big is it. Like, for example, if you start from scratch, you can just query how big is my cache now. And what speed am I getting? So there's
But if you're serving to more and more users, I wonder how much.
that's a bit more interesting. So for that, I will. So you can use S3 bat and be strapped on one service. You can use S3 bat. So you, like for example, through AWS, you could probably do that kind of like filtering. How much traffic who's going to this type of stuff. You can do that on the S3 side as opposed to directly.
And for a single VM or a single laptop, you can do what Lara did, install and configure some VMFS. Then you're talking to the public mirror servers. Or CDN, right? Cloud layer CDN. But what you typically do as an HPC cluster is you install or set up a local mirror server yourself. And then you're essentially syncing everything that EasyBuild has locally, and then it just stays within the network. So it's a one-time copy from the public mirrors, and then everything is local.
And that's when there's not, there isn't. Dude, you're using a lot of American technology, as in Amazon, out there. Is there any chance that you're considering European?
So we only do it because it's flexible.
Yeah.
And we're not tied to them in any way. The central server for Easy is running in the Netherlands at the university. That's the key part of campus. That's a physical server with the YubiKey that we have full control. Everything else is just convenience. The mirrors could be anywhere. We have a mirror in the UK at Val. We have one in Azure, US East. We have one in AWS, which sits in Dublin, in their data, in the data center in Dublin. But they could be anywhere. If that's trouble, we could just do mirror servers at European universities, whatever. European cloud providers, whatever makes sense.
Yeah, but then the technology they'll be using is what exactly? Like if you set up a mirror?
A mirror is HTTP. It's an HTTP web server. So nothing, just you install certain VMFS, fully open source, you don't need anything special in terms of. Also, everything we do in Easy is done with open source tooling, and we don't use anything vendor specific. We don't use any AWS services, tools, whatever.
Yeah.
Same thing in Azure. We use Magic Castle to spin up Storm clusters, which is an open source project. We use Terraform,
Magic Castle uses Terraform.
Magic Castle uses Terraform, yeah. So everything we do is with open source tooling, and we make sure we're not tied to any one thing. And we also tell this to Amazon, like, we don't care about all the services you provide, we'll just do standard stuff. Spin up VMs, and if the funding or the sponsoring that we get from you dries up, we just jump to someone.
The convenience that you get is access to hardware.
Yeah.
Right, so with AWS, you can get access to the physical hardware that we're building for. With other places like new AWS regions, you don't get access to the old hardware anymore. They're not installing these things, right? So then it becomes a bit more interesting these days because now like you can use QEMU in these kinds of services, so you can kind of in some way get access to old hardware just by using QEMU. Like have native level performance, so that kind of works. But that only works in the x86 space. So in like the ARM space, you still need access to the physical chips, and so that's something that we get from them that's going to be hard to replicate unless you have a Frankenstein. So unless you create something that has the missing parts, because we can have a build cluster that's in AWS or somewhere else. And we can have another one that's somewhere that's in another location that's also contributing. That's what we do already.
And also that aspect, our main building is now done in AWS, but for Fujitsu A64FX, we built in Portugal on the counter. We have a GPU build bot in Ghent and at Surf. We do NVIDIA Race and Jülich. So these things can be scattered across different places. We're fully agnostic. Right now, all we need is Slurm. You can get Slurm for half. And even that can be removed.
And even that, you could say, we could use Flux, right? Then we wouldn't need the cluster anymore.
Flux or just a Linux VM with a bit of work. So it's all, we're very aware of not tying things into We're not even, technically speaking, specific to EasyBuild. I keep saying this, but the door is open to use other things. If there's anything close to it, we could use that.